Hello, my name is Bernhard Baumgartner and today I'll show you how you can use the Omicron Lab B-WIT100 wideband injection transformer to measure the stability of switched mode power supplies, linear regulators or any power supply you have. To measure the stability of a power supply with the signal injection method, we require an injection point. We do this by adding a small injection resistor into the feedback loop. The important thing is that this resistor is small in comparison to the power divider. Now we can use this resistor to inject a signal into the feedback loop of our power supply using the wideband injection transformer B-WIT100. What you're now doing is we inject the signal here and then it runs through the feedback loop and the filtering and it appears again at the output of the power supply. And by comparing these two signals, we find out how stable our power supply is. To do so, we require two oscilloscope probes, which we connect to our Bode100. We connect the reference input of the Bode100 to the signal we inject into the feedback loop. And the second channel of the Bode100 we connect to the output of the power supply. And now we have the possibility to compare these two signals. In fact, it's a gain measurement, so we are comparing two voltages and we get the open loop gain of the power supply. In an optimized diagram, this would look something like this. Now, at the point where the gain crosses the 0 dB line, we can measure our phase margin. And the bigger the phase margin is, the better and the more stable our power supply is. On the other hand, there is a point where the phase margin crosses the 0 degree line, and here we can measure the so-called gain margin. The gain margin is also an indicator how stable the power supply is. For our measurement, we are using the voltage regulator test standard board from Picotest. It has an LM317 linear regulator on it, and we are using a J2111 current injector as a constant current load to have a 25 milliamps load connected to our linear regulator. The Bode100 is connected with the B-WIT100, and we are using two standard oscilloscope probes to pick up the voltages as explained earlier. And now let's see what our result is. To assess the stability of our voltage regulator, we are interested in the point where the gain curve crosses the 0 dB line. In our case, this is around 6.3 kHz. And here we measure a phase margin of 114 degrees. Fine, you might say, I have a stable regulator. Unfortunately, this is not the case. Our signal level is too high and therefore we are getting a wrong result. How can I find out about this? Well, I just reduce the signal level, let's say by minus 10 dBm. And if the pass-through point moves, we see that we have done a wrong measurement. To find out the right signal level for this measurement, we have to further reduce our signal level. And then, as soon as the pass-through frequency no longer moves, we have to slightly increase our output level. And if then the pass-through frequency remains stable, then we know that we are measuring linear and therefore we have found our right frequency bandwidth of our voltage regulator. So let's try that. I set the output level to minus 27 dBm and now I check the pass-through frequency. The pass-through frequency is now around 60 kHz. When I increase the signal level again by 6 dB, the pass-through frequency remains stable. This shows me that I'm now in the linear area of the measurement and therefore the result is valid. So I measure a phase margin of approximately 90 degrees at 60 kHz for this regulator. But due to reducing the signal level, we got some noise into the curve. And how to get rid of this noise, I'm gonna show you next. As mentioned, a little noise in the curve is okay, but there are some occasions where you require a smooth curve, for example, for documentation purposes. For that reason, we have implemented a feature that allows us to change the signal level over frequency. We call this function the so-called shaped level function. We have programmed a frequency curve that increases the signal level over frequency in the area from 100 Hz to about 3 kHz. In this area we have noise in our curve. By applying this, we get a smooth curve for the gain. Measuring the stability of voltage regulators and switch mode power supplies is quite easy with the Bode100 and the wideband injection transformer B-WIT100. To find more about this topic, visit our webpage www.omicron-lab.com. Thanks a lot.